Well, somebody wanted a musical introduction from me. This is what you get. Alright, now that you've been entertained, time to get to work. Today, we'd like to be able to identify properties of rational functions. And sketch graphs. Now, remember that rational is pretty much the same thing as a fraction. So we're talking about functions that look like fractions. So if we look at a generic one, f of x is equal to p of x over q of x, where p of x and q of x are polynomials. Now, a polynomial usually has a domain of all real numbers. However, we're going to exclude any numbers that make q of x equal to 0. Right? We don't want to divide by 0. However, sometimes it's interesting to wonder, what if q of x equaled 0? Well, we'd have something called a point of discontinuity. Now, what does that mean? That means that the graph has some sort of break there. There's a hole, there's an asymptote, something is happening right there that two branches of the graph aren't meeting up. Now, usually, like I said, it's an asymptote or a hole. But how can you tell the difference? Well, let's take a look at an easy one. Nice, simple little rational function. 1 over x minus 2. Now, if I think about this, if I said x minus 2 equals 0, I get x equals 2. So that tells me I have some sort of discontinuity at x equals 2, because that'll give me division by 0. So if I thought about sketching this thing, and we use the idea of transformations, this minus 2 tells me that I would slide 2 to the right, and I'd have a graph that looks like this. Okay? Right? All it did was it gave us a vertical asymptote at x equals 2. So that's an asymptote. Now, what about a hole? Let's say that I had something along the lines of f of x is equal to x times x minus 2 over x minus 2. Well, now if x equals 2, I get division by 0. So I've got something going on there. But if I let x equal 2, I get 0 in the numerator. And the thing is, I can cancel out those two factors, and for all practical purposes, this becomes the function f of x equals x. And well, we all know what that looks like. However, we know that when x equals 2 and y equals 2, we have a hole in our graph. And we represent that with a little circle. And we draw on our line, going through the origin, slope of 1, and it has a hole at x equals 2. Now, we've talked about vertical asymptotes. The next thing to do is to consider what our book calls horizontal asymptotes. That's kind of a unfortunate term because further on we'll learn that these aren't always horizontal. I prefer to call them end behavior asymptotes, or simply EBA for short. Now, we've got some rules for EBAs. Rule number 1. If the degree of P of x is less than Q of x, then y equals 0 is the end behavior asymptote. Okay, so quick example of that, f of x equals 1 over x. Right, simplest example, x-axis is a horizontal asymptote or an end behavior asymptote. Rule number 2. If the degree of P of x equals Q of x, then the EBA is a ratio of the leading coefficients. Right, for example, f of x equals 2x squared over 3x squared, right? Second degree over second degree, y equals 2/3 is the EBA. Now for the last rule, the degree of P of x is greater than the degree of Q of x. When that happens, for right now we're going to say there is no end behavior asymptote. Alright, and this is a good time to stop this video. I'm going to do a couple examples in the next video. If you want to go ahead and watch that one, feel free. Otherwise, we'll end it here. Have a good night. See you on Monday. Bring any questions. We'll get them cleared up. Thank you.